Hey, it's Tony from Adafruit, and this is a quick look at Jupyter or IPython. And these are really interesting tools that let you use Python in your web browser, so in a notebook. And it's something you might not have heard of, or maybe you have heard of it and used it before. It's used a lot in kind of the data analysis community, where you want to use like a lot of these Python libraries like NumPy and SciPy to really analyze interesting data sets. But I was thinking, it is a really useful just general Python tool. So it lets you run Python code, write Python code in your web browser. And it could work really well on a Raspberry Pi. In fact, it does work really well. And so I just wanted to show what Jupyter is, just give some basics on how to run it on the Raspberry Pi and how you might want to use it yourself potentially if you're doing like Python code, especially things that like talk to hardware, if you're trying to prototype some things or get some quick measurements and things like that. It has some really interesting capabilities, I think, that might make it worth checking out yourself. So let's just kind of dive in. We'll get started here. So I'll go into the desktop view, or the main view here. And you can kind of see, so in the upper right, I just have, this is the Pi 3. It has the camera. This is the same one I'm using for the cat laser project, so I didn't want to take that apart. But you can use any Raspberry Pi, it really doesn't matter. In fact, like the Pi Zero you could use, although you probably want it to have network access, so I've got it connected to my network here, because you will run something on your Pi and access it from a web browser on like your laptop or your computer. So you do want network access, but you could even use like the built-in Wi-Fi on the Pi 3. Anything should work there. And then just connected to it, I have, this is the MCP 9808 precision temperature sensor. Real nice little low-cost I2C temperature sensor, nice accuracy on it. And I'm just using this as an example. So what I wanted to show is, let's connect my Raspberry Pi with a Jupyter or an IPython notebook and then graph some of the sensor data. So we'll read some of these sensor readings and graph that using the tools that it has. And I'll show you that you can do it all just using the web browser pretty much here, and it's pretty straightforward. Now this web page here, this is the main home page for the Jupyter project. And I'll put a link down below in the description, so when this is up on YouTube, you can look and see the link directly to this. And just a little bit of history, so I'm not super familiar with Jupyter. I am more familiar with, so IPython and Jupyter are the same thing basically. So the last, I don't know, maybe 2-3 years ago, they kind of merged the projects together and they renamed it to be Jupyter basically. So it started out as IPython, where I is just the uppercase IPython, stands for Interactive Python. And it started out not as a web thing at all. It was actually a little Python kind of REPL, you might hear it called. So a read, evaluate, print loop, where you can just run this tool and you can run Python code interactively, basically. So, you could build up a data set and then maybe graph it. And it started out just as like command line kind of tools. But over time, they added what they call the notebook capability, which has really turned into like the star feature of this whole system. And that lets you have that same interactive Python shell, but in a web browser. So you type in your Python code into the web browser. It'll make more sense when I start showing some of the examples here and how to use it. But that was a pretty big and powerful thing, in that now, you don't need to be like some super command line expert. You can run a tool. It's a little more visual. And it really follows this notebook metaphor where, think of like a scientist where maybe you're researching something and you're looking at, like, you're running experiments, you're getting data, you're analyzing that data. And so you're building up all of this information that's probably scattered across like paper notes, maybe electronic notes or something. So I think the whole idea here is that you've got actually like a web notebook where you put all of that information. So you put your code that runs your experiment, you put your code that graphs your data, you put the code that analyzes the data, you can put comments, you can put, descriptions and things like that. So really powerful thing, and that people have taken this and kind of run with it. I mean, I've seen like tutorials on how to learn programming or learn like data analysis that are all just these IPython or these Jupyter notebooks. And so I think you'll kind of see why this is interesting as we play with it more. But that's what it is. So Jupyter, so if you hear IPython or if you hear Jupyter and you get confused, which it is a little confusing, they're the same thing, because they kind of realize that this power isn't just for Python. So like it would be nice to have, Ruby or other programming language. So you can kind of see here like all these different programming language icons. They all fall under this Jupyter kind of name, in that Jupyter is this concept of a programming notebook, And then the languages that plug in could be anything. So of course there's a Python language, and I think they actually still call that IPython, but there's all kinds of other languages you can plug in too. So, you know, stuff like, it looks like PHP or JavaScript or Lua or F# or whatever. So really cool. So they definitely want to take this beyond Python. So when you hear Jupyter, you don't necessarily have to think only Python, but it is something that works really well and has a lot of support for Python. And so that's why I think it works well with the Raspberry Pi, because a lot of the Pi coding that you do is probably going to be using Python, or at least if you're using a lot of the hardware libraries that we have, they're written mostly in Python. So being able to use Python and looking at tools like this, I think is kind of interesting. So this is the homepage. It tells you a little bit about it. Again, it kind of talks about, you know, here's the basic idea. You make these web notebooks and things, and that you can put code inside of it. And then it kind of gives you some pointers here so you can like try it out. But we'll just get started. So I'll show you how to install this on the Raspberry Pi. Because again, it kind of runs, you have to run this server that will then kind of serve your notebooks up, and then anything on your network can go and access those. You could access it from your Raspberry Pi if you're in like the Pi desktop, but it's going to be a little slow. Like the Pi web browser, you know, is not the fastest thing in the world, so you'll probably have a little more luck with it, or be able to you know, have more, be more usable if you're using your own web browser on a laptop or your PC. So if you go to this install the notebook page, it gives you a little bit of info about this. So again, because this is coming more from like the data science world, it focuses a little more on those kind of users and how they use things. So it kind of dives in and says, hey, you probably want to use like Anaconda to install this. And if you've never heard of Anaconda, that's a binary Python distribution. So basically you can install this and it gives you Python, but then it gives you all of these extra tools on top of that, like all of the scientific computing stack that's Python is becoming pretty famous for. So it's really easy, especially on Windows, where like compiling all these libraries is a very non-trivial process. Like you have to install the right version of Visual Studio. It's a mess, frankly. You really don't want to compile Python code on Windows, which I think is unfortunate because, boy, it's so much easier on Linux and Mac when you can compile this stuff. I think that stuff is changing. Anyways, long story short, Anaconda is how most Windows users use IPython and Jupyter. Now, remember, we're going to run this on the Pi, so even if you use Windows as your operating system, that's okay, because we're just going to install IPython and Jupyter on the Raspberry Pi, and then from your Windows machine, you can use any web browser or whatever to access this. So don't worry about it. You don't need Anaconda installed, so we'll skip that. Then the next thing they say is for the experienced Python developer. So hey, you're experienced because we're going to use this option. You can use the pip tool to install this. So it installs just like a Python library. Now do notice they mentioned to use Python 3. So they have pip 3. And that's just because the current version of IPython or Jupyter, I believe, is the last one for Python 2. And so all future versions are going to use Python 3. Luckily for us, we've ported all of our Python libraries over to run on Python 3 and Python 2, so you should be okay to use Python 3. I mean, I think it's 2016, it's time to use Python 3. So that's what I'm going to use here. We'll use Python 3, but just be aware of that. Like, you know, if you just go in and if you start using the pip command, that's going to use Python 2. Okay, so but before we get started, so like I mentioned, because this uses Python 3, we just want to make sure that we have Python 3 installed on the Raspberry Pi. So make sure you're running the latest version of Raspbian. The Jessie operating system is probably what you want to use these days. You know, Wheezy is pretty much deprecated. And then, of course, first go in and do all the standard Raspi config that you want to do. So, like, I'm connecting my Raspberry Pi. This is an SSH session right here. So run the raspi command, expand your file system, you know, make sure you've got all the available space. If you're going to use hardware, like some of the libraries, like this little MCP sensor, I know that I'd need to enable the I2C interface inside of here. So do all that stuff. And then, you know, of course, it's going to have you reboot, but I'm not going to change anything. I already did that here. So then after you do that, you want to do sudo apt-get update. So this will just update all of your packages. I'm going to skip running this just because it downloads a bunch of data and that's really slow when I'm streaming. But make sure to update your package index. And then now to install Python 3. So you want to do apt-get install Python 3, Python 3, oops, let me get this right, Python 3-pip. So this installs the pip package manager for Python 3 because it's totally separate from Python 2. And then Python 3-dev. This installs all the headers that you need to compile Python extensions specifically for Python 3. Generally, if you're installing pip, you also probably want to install the Python 3 dev package because you're gonna run across some package that you need to compile code for, especially if you're using our hardware libraries. Almost all of them require compiling some code, but it's easy. Just install this Python 3 dev package and you're good. And then one more that's IPython or Jupyter specific. Install Python 3-matplotlib. So this is the matplotlib library, which is what Python can use to make a graph of data. And I'll show you why. Like, we're going to graph some sensor data, so you need to have this installed. Now, there are other ways to install this, and unfortunately, so because I'm using apt-get, this is going to use the Raspbian repository and the code that it has there, which is a little bit old, but it's new enough that we can use all the features we want. But just be aware, like, this is going to install matplotlib 1.4, and I think the current version is 1.5. So if you want like the bleeding edge, latest features, then you probably need to go and like compile it and install it yourself, which isn't too hard. I think you can actually just use pip to install it, but be aware, it might be a little more advanced. It's a lot easier to install things generally with the apt-get package manager here, so we'll do that. So I'll run this. I've already installed these, so it's just going to say everything's the current version, but it's going to run for a little while for you. And then after you've run these commands, then you've got Python 3 installed and you're ready to go, and you've got all the dependencies. So now to install the Jupyter package, we just want to run the command that they mentioned here. So pip3 install Jupyter. Now I'm going to run sudo pip3 to run this as root, just so I install it globally. But it's you could go either way. You don't have to run this with sudo. It's just that I'm not sure if you run this without sudo, it probably won't put this Jupyter command into your kind of main system path, and so you might run into some weird things. So I would just say, use the sudo command, install this thing globally. So I'll run this, and it tells me I've already got installed. But for you, it's going to spin for a little while and install this thing. And it actually takes a little while to install it because it's compiling some stuff in the background. So it takes, it took about 5 minutes or so to do this installation. But once it's installed, then the way you use it, and they mention here in the installation or in the docs, now go into the running the notebook section here. And so this mentions, okay, you can use this Jupyter notebook command to start it. Now, one big thing, and it's a little bit of a gotcha, because again, in that scientific computing community, most people are running Jupyter on the same machine as they're accessing the web interface from. But because we're going to run Jupyter on our Raspberry Pi and then access it from our machine on our network, we need to tell Jupyter, hey, make sure to allow people on my network to access the notebooks that you serve. And so by default, it doesn't do that. So if you just ran this Jupyter notebook command, you could only access it from a web browser on the Raspberry Pi, which is probably not what you want. But I'll show you, there's an easy little command that you can give it, or a parameter to say, hey, allow anyone to access this. So what you want to do, you want to run the Jupyter command and then notebook. So this is a sub command, and you can actually run -- help, and it will print out a little bit of extra parameter info here. So it tells you, like, you can specify an IP address that you want it to listen on, a specific port to listen on, that type of stuff. All kinds of little options here. But what we want to do, we want to run Jupyter notebook and then do -- IP. So we'll give it an IP address to listen on, and set this equal to 0.0.0.0. So this means listen on any network interface, basically. So allow connections from outside the Raspberry Pi to access this notebook. So we'll hit enter there, and it takes a little bit of a second here, and then it's going to start up. And so you should see something like this. And it's okay, it gives you this warning that no web browser is found. When it runs, it tries to open the web browser on your machine because, again, this comes from that scientific computing world where they're usually running it on the machine, but we're not doing that. There is a command line option to disable this. I noticed the -- no browser option, but it's kind of annoying. It's like, I don't want to type that in. I mean, sure, I could just to get rid of this warning, but it's not the end of the world. Part of me thinks, like, maybe it should just default to not open the web browser, and if I want that behavior, maybe I should give it a command line parameter, but I'm sure there's all kinds of legacy reasons for this. Anyways, though, just make sure you don't see like an error or something like that. It looks like it's running here. It is important to notice that it's telling me it's running the server on 0.0.0.0 port 8888. So that's the special port that I need. And so this means that I can access my Raspberry Pi's IP address, and even though you see 0 here, this just means it's listening on any network interface. But then as long as I access the Raspberry Pi IP on this port, it'll serve up the interface for that. And so for me, luckily, because my router will look up the host name of my Raspberry Pi and resolve it to the IP address, I can actually just go in my web browser here to Raspberry Pi port 8888, so the ;8888, 4 8s. And if I hit that, then here it is. So this is Jupyter running, and it's not too fancy. I mean, you're basically seeing a web interface of your Raspberry Pi, and it's actually pretty cool. So like I mentioned, I'd used IPython, I'd used Jupyter before it was called Jupyter. So IPython, gosh, I probably started using it 5-6 years ago, a long time ago, because at the time there was really nothing else like it as far as a data analysis tool. Just a really powerful thing. I mean, there still really isn't much like it. Even like commercial stuff, I'm really amazed. Like I think I think MATLAB maybe has like a notebook concept kind of like this, but honestly, the Jupyter world is just so big. It's just taking over the whole data kind of analysis world. But anyways, though, so this is cool. Like I haven't seen this since I've started, using this newer version of Jupyter. It looks like it gives you a view of the files on your Raspberry Pi. Like, so I have a directory here. It's showing like I have some files in here. I'm guessing I can look at these things. So yeah, that's kind of cool. Like, this is, I mean, maybe just a basic like file editor for your Raspberry Pi that's all web browser based. So that's kind of cool. I mean, you might just play around and kick the tires and see what you can see here. But I'm going to go back to the home page here. And so, okay, so the big thing with Jupyter is that you create a notebook, like I was saying. So a notebook is a place where you can mix code and data. I mean, think of it like a physical notebook where you're writing things down, but this is a special notebook where you can write things down and you can have the computer run that code that you wrote down inside of there. So let's make a new notebook. We'll go to New, and then we'll say Python 3 notebook, because like I mentioned, remember, this uses Python 3, so you really need to use Python 3 kind of going forward with this. And it just starts out, and this is basically what a blank notebook looks like. So you can give it a title, which we'll give it at the top up here. So we'll say Jupyter test, maybe something like that. And the important thing to know is that, okay, so what's happening here? Jupyter, so I mean, you can go back and actually see, it's telling me, hey, like someone's accessing it, it's giving me a little log here, and then it mentions the kernel was started. And so what that means is that it's actually running Python in the background. And so if I put some code into this block right here, like let's say print hello world, something like that, then it can actually take this and run this code with the Python process that it has running in the background. It calls that a kernel. And the way to run this code, so you can actually go, so this is called a block, where you can put like code, and I'll show you there are other things you can do in a block, or a cell actually, I think is what they call it. And inside of a cell, you can put code or you can put other things. Now you can, when you type in code, and you can have multiple lines. So I'm in here, I can say print hello world, print like second line, something like that, inside of here. Now to actually run this code, so it's not just instantly running this code, like I hit enter, nothing's happening because it's not running that code yet. You need to explicitly say, okay, run this cell. And it's got a bunch of options, like you can run all these cells. I'll show you, you can have multiple cells, but just for the current selected one, we can say run cells. And then notice this, okay, cool. So it just printed out hello world and second line. So it ran the code right here and then gave me the output of that command below it. So that's pretty cool. I mean, like you could write an entire Python program and then just run it inside of here if you wanted. Now you can add extra cells. So I believe there's like an insert cell above or below, but here's what you want to do. If you really want to use Jupyter, go to the keyboard shortcuts. And there's a lot of them, but start to look at like, when you want to add a new cell, look up what it is to add a new cell. And there's actually an A command to add a cell above the current one, or a B command to add a cell below the current one. And so if you start using these keyboard shortcuts, it makes things a lot quicker, because it's like, okay, I had some Python code here. Now, if I press B, notice it just added a new cell below this one. And I can maybe say, foo equals, how about hello, something like that. So we'll set a variable equals that. And then I could say press B. Oh, so this is interesting. When it's green, I'm in edit mode. So whatever I press is, going to be editing this cell. If I press escape, then notice it turns blue, and now I'm in command mode. And then if I press B, now I can add a new thing. And here's the important thing to realize, that it's still that same single Python process. So I can add an extra cell, but this cell can reference anything that the previous cells have done, or anything that's actually changed the state of that Python process that's running. So like global variables or modules that have been imported, all of that stuff is still there. So, other cells can use that. So if I print, maybe the foo variable inside of here. So let's run these. Actually, let's run this second one first and see what happens, because I haven't actually run this one above here, so I haven't set this foo variable yet. So think what might happen here. And you can actually notice every time I run a cell, there's a number that's placed inside of these brackets here. And I think that's telling you like the order that your cells have been run. And so it's just going to keep increasing as I run things. Let's try to run this one. And a shortcut for that is Shift and Enter. So if I press that, then it tries to run the cell. But uh-oh, I got a Python error here. Foo is not defined. So, you know, again, that makes sense because I tried to run this command, but it didn't know what this foo variable was set to because this cell above hasn't been run yet. But if I go to this cell and I press Shift Enter, I don't get any output because just assigning a variable in Python doesn't really give you any output. But notice, you know, this ran, I saw this change to 3. And then if I go back down to this cell and I press Shift Enter, then now we see, hey, print foo, and we get the hello value inside of there. So that's pretty cool. I mean, you can start to see, and it's really nice. I love the interface of this, how, you know, you're mixing your code and your results inside of here. You can start to see how, especially with like analyzing big data sets where you don't really know exactly what you're doing. You're really exploring something. You're prototyping, you're running something, seeing what the results are, maybe running some different commands based on those results. So you're building up this process, and it's really cool how you can document that just by, you know, creating these cells, saving their outputs, being able to see all this stuff. Now there are other types of cells, so if you go up to this menu here, so I have like this bottom cell down here selected. Right now it's a code cell, but you can actually make it into a markdown cell where it will interpret the markdown kind of language, where this is how you can like document things. So markdown has a little bit of a syntax. If you use the pound character here, then this will make this line a heading, like a large text. So we can say, you know, how about hello world, something like that. Oops, let's spell it correctly. And then, you know, I could put like, this is a paragraph of text or something like that. And maybe, you know, this is a list and this is a second item in the list, something like that. Now, if I hit Shift Enter, see, this converts this into markdown code. Or, well, it actually renders this markdown. So that's pretty cool. So, you know, if I could actually like create an entire living document. And there's actually a whole style of programming called literate programming that you may or may not have heard of, where basically your program is documentation. So like all of your comments are describing like your design decisions. You describe how this function works, but you also describe, you know, here's why this function is here, and here's like maybe the algorithm behind it, and why I've used this algorithm, and, you know, all this interesting stuff. Like, there are actually entire books that are written as literate programs where, you know, all of the comments become the text of the book, and then the source code is interleaved inside of there. So you can see how you can do that same type of thing here with this IPython notebook. So, you know, maybe you're analyzing some data, and then you're like finding out some interesting stuff, and then you're starting to save those conclusions as text in here. And so that's pretty cool. And again, so this notebook, like this thing is a file that exists. So you can save this, you can close it, you can open it. So I'll just say like close and halt. So this is going to close this notebook. And notice it's saved here as a Jupyter test.ipynb. And so basically this is an IPython notebook file, and it remembers this state of what was last run. So if I click this thing and open it again, then we'll actually see once it loads up here that it's going to basically show you what was in the notebook before. So it's showing me the output that we saw before. Basically, you know, here's the hello world lines and things like that. Important distinction though, it's not actually rerunning all those cells again. So I actually, like, it remembered the output and it saved the output inside of here. So it's not just rerunning these automatically, but I can go back, and if I press Shift Enter, you know, hey, it's just gonna run this line again. And you can go back and edit these things too. So if I wanna change this and delete that, and then Shift Enter, so there you go. So that's the basics there. Okay, so that's pretty cool. That's some basic stuff. I'll also point folks at, if you wanna learn a little bit more, go to this page that I'll put a link to from down in the description. So this Introducing IPython, this is just from the official documentation. And it's kind of funny that it uses IPython, because I think they should actually say Jupyter, but I don't know, maybe, like I said, the naming is a little confusing because they're transitioning to Jupyter. But anyways, this introducing page is actually really nice because it highlights some of the high-level commands that are actually really interesting and really powerful in Jupyter and aren't as immediately obvious, because it's pretty obvious, like, it's cool, this is really nice for running Python code, but there's more than just Python inside of here. So like they said, there's a concept of these magic commands where they start with a percent sign, and I think if you just type magic, and then if I shift enter this, yeah, so it tells me about these magic functions. And so there are a lot of these functions where it's not Python code, it's a function that's telling Jupyter, hey, you know, do something else. Like maybe I've got some, you know, something outside of Python I want you to do. So they talk about, like, you can do aliases of commands. You can do all kinds of funny, like interesting stuff inside here. You can like change, you know, how things are configured. But these are pretty powerful, and there are a lot of magic commands. I think they kind of mention a few. Oh yeah, they mentioned like there's a quick reference in here that you can get to. And then they talk a little bit more about these magic commands down here. There are some good ones. So there's like a load command that can load a file on the Raspberry Pi. So like let's try this load command. So I can do load, and actually I think I can do load question mark if this will give me help. Let's see what this does. Okay, good, that works. I wasn't sure that was gonna work. And let me just go, let's just see if this is actually, if I just do load. Okay, good. So yeah, so if you put a question mark at the end, then that actually gives you the help and the usage info. And by the way, if you want to delete a cell, select it in this command mode and press D and then D again, the letter D. So DD, kind of like, I think VI. So DD, that deletes the cell. But anyway, so load question mark, this tells you about the load command. So this can load a source file from somewhere. Like that somewhere could be on your Raspberry Pi. I noticed though it can actually access from a URL. So they give you some examples here. Like you can load, you know, if you have a Python script on your Pi, you can load it up in your notebook and start editing it right here. Or if there's like an example file from the internet, that's pretty cool. You can just put the URL directly inside of there. So that's cool. So like let's try to load maybe something on the home Pi. And I have this Adafruit Python MCP 9808 folder already. And I just pressed tab. Notice it did that tab completion. So it's a very powerful editor. It's smart about knowing, okay, you know, you're looking at files, and so I'm going to do the tab completion based on that. So again, everything is very smooth and very well polished and easy to use with this, which is cool. Now I have an examples folder, and then there's a simple test example inside of there. So if I run this, then notice that it just actually loaded up, and I'll close this little help down here. Here's the contents of that file. So it just loaded this example file directly inside of here. And I can go in and I can start editing this, you know, we can say like foo or something like that inside of here. And that's cool. And I can press Shift Enter and run this. I'm not going to do that yet because I don't have the library installed. But again, so I just wanted to show you, there are these magic commands. They can make your life a lot easier. Another command that's super useful, and it's not technically a magic command, I don't think, but if you use an exclamation point, then it will interpret whatever you type here as a system command to run on the Raspberry Pi. So if I just run exclamation ls, then that's going to run, I press Shift Enter to execute this. This runs the ls command from the current directory that the notebook is running in. And so, you know, I could actually do something like maybe apt-get, how about show package Python 3 or something like that. So, you know, I can run a, oh, interesting. That's weird. Why? I don't know why that failed, because that should work on the Pi. So just out of curiosity, I'm going to go back. Let's connect. I'm connected to the Raspberry Pi right here. Let's do apt-get show package Python 3. Huh, oh. I'm blanking on what it is. There's a, oh, it's apt cache that you have to do. I don't know why Debian has the difference between this. So, okay, so that's why this command isn't working here. So if I do apt cache show package, but this is maybe a good example because you can see, so, you know, I ran this on the Pi itself in an SSH session, and you get this kind of output. And then I just ran this in the IPython shell right here, and you can see, you know, I get this output. Now, okay, yeah, here's how you scroll down through it. So it's, you know, maybe not as pretty, but this is pretty powerful. So like, let's say you're looking at a tutorial or something. So like, here's this MCP 9808 sensor tutorial, and you're looking at, you know, you got the hardware wired up for this, you're all good there. You go into the software for this, and it's like, oh man, here's a bunch of commands I need to start running. So, you know, you can just copy these out and start running these in your IPython shell right here. So maybe, how about, let's delete this cell, And maybe we'll delete this one too, and yeah, let's delete that one. We'll keep this a little bit fresh. And let's just put in some of these commands then. So, and again, so each of these I'll put on a separate line, and I have to put this exclamation in front of these. But let's run this. So, and this command, so this is one annoying thing, because if any command asks for input from like standard input, it's not going to be able to send that input. So the apt-get command normally says, you know, yes, no, do you want to install these? So I'm going to do the -y option for install, and that's just going to automatically answer yes for this. Now if I shift enter, it's going. It's kind of cool. You're seeing kind of the in progress. I guess I shouldn't have done that, because now I'm running the update command, which it takes a little while. I guess it's pretty quick. We'll see how this goes. But so this is running all these commands, and it's pretty cool. I haven't seen this until now. I think they must have done this only in recent versions, but it's just streaming the output as it gets it very fast to your notebook here. So that's pretty cool. Like in the past, it would just spin and spin and spin, and then you'd get this big blast of, you know, here's the results of the command that you ran. And you can also notice too, as this is running, you get a little star right here instead of a number, because it's kind of telling you like, okay, hey, this thing's still going. You know, don't stop it yet. Now you can stop this. There is under this kernel command, you can interrupt the kernel, which basically sends like a Control-C, a interrupt signal, I believe. And that'll stop whatever process is running. And in fact, I'm going to do that. So I'm just going to do the sig interrupt, because I've already installed this stuff for this package. But basically, you know, this is pretty powerful. So you can follow along, you know, with these guides and run commands and things directly from this, and it works pretty well. Now there were a few gotchas, because I tried to go through that scenario of, you know, let's install a package directly from the Jupyter command prompt here, and it does work. I mean, you know, like I probably want to. So I don't know. Let's run the ls command. Let's try it. I'll show you what I ran into, some of the issues here. So, you know, here you can see I'm in my root directory. So let's make a new directory called test, and then let's change to the test directory. And now let's just ls to see the results. And so now, you know, I should see there's probably no results. Oh, that's interesting. It didn't change my current working directory. Okay, maybe this is not a good example to show, because I thought that I'd be able to change into that test directory. Again, like I said, I'm not as familiar with the commands here for this. So, but the root problem I was trying to get at, and that I was going to try to demonstrate here, is that because this Python process is running in the background, if I run commands that install a Python library, like if I'm following, you know, this guide here that says install this Python library, my Jupyter notebook doesn't actually get that library installed until I restart it. And I believe that's just because it doesn't look at your system Python packages until it restarts again. So it's a little weird and it's unintuitive, and it tripped me up for a little while. You know, I installed something and then it's like I'm trying to use it and it's failing. So what I think the easiest thing to do would be, like, let's say I want to start using this temperature sensor. Before I run my notebook, install the library for this. So I'm actually going to close this notebook. We'll say close and halt. You know, we'll cancel out of this whole thing, let it do its finish up. Yep, okay, we'll leave this site. And then I'm actually going to go back, and so this is the terminal that's running IPython, and I'll just press Control-C. This is how you stop it. So you press Control-C, it asks if you really want to shut it down, and yeah, I do. So that shuts down the kernel. So now at this point, I want to go and install my library, because now after I install my library and then I run IPython, it will pick up that that library is installed and everything works the way it should. If I didn't do this, though, I'll mention kind of what error you can get when we get to that point. So, okay, so let's just go back to this guide. And again, I'll put a link in the description below if you want to check this out. But really, any Python thing should work for this, you know, because this is just going to use the Python that's installed on the Raspberry Pi. So, okay, so for this library install, we need to do this clone command. And I've already actually cloned it on my Raspberry Pi. So I've got my the code inside of this directory here. So I don't need to run this command. And it's really just this Python setup.py install command. Now, big gotcha though. Remember, because our notebook runs using Python 3, I need to install this library with Python 3. And this Python command right here installs for Python 2, because Python in Raspbian means Python version 2.7. But I want to use 3, so what I need to change this command. So I need to run sudo python 3 setup.py install. So notice the 3 at the end of the Python here. So that's going to say use Python 3 to install this library. So I'll do that. and it's going to go through and it's just did a quick little install for this. Okay, so at this point, now I should be okay. So I'm going to go back to my root directory, and let's go back and run that Jupyter Notebook command. And again, remember, use that IP equals 0000 so that you can access it. I'll show you actually if I don't do this. So I can run my notebook, and we'll see what it does. So it's going to start up. Now notice here it says it's running at localhost 88888. Now if I go back here, and if I try and access Raspberry Pi 88888, then can't be reached. And that's because it's not listening on kind of all the network or all the public interfaces for this. So I'm just gonna hit Control-C to stop this and then run it using the IP equals 0000 option for this. So a little thing, it's easy to miss this, and then suddenly it's like, why isn't it working? Okay, so now it's running notice again, so it's 000, and now I should be able to hit this. So I go to that, and okay, cool. So and then let's open up our Jupyter Test Notebook again. So okay, takes it a second here to load it up. And then, okay, cool. So now we can see, here's all of our stuff, and you can see all the outputs. So I'm just going to delete some of these cells. I'll delete this one, we don't need that, delete that. Let's just start fresh. We'll just delete everything. So just delete all the cells. Okay, cool. So let's say, so I just installed my Python library for this. Let's get that example code again. And remember, you can use that load command. So, and I'll show you different ways. So the load command before, I used loading the file from the Raspberry Pi. Let's load it from GitHub itself, so from the web. So this is the Python code that I just installed. This is the GitHub repository for it. Here's the examples folder, and here's that simpletest.py. And if I go to this raw link, then this actually has the raw contents of this file. And I can copy out this URL right here. And if I put this in as a parameter, so this is cool. Here's just a web URL, and if I run this, look at that, it just downloaded the file and threw it into my notebook here. So that's nice. I like that a lot. That is super, super handy and cool that they did that. And now, looking at this code, there's nothing I really need to modify. I've hooked this up exactly as the tutorial shows. And again, remember, you got to enable I2C on the Raspberry Pi. Let's hit Shift-Enter. So, I mean, if just looking at the code, like it's just going to go into a while loop and then just print out temperature sensor readings. So I'll hit Shift-Enter. And hey, look at this. This is pretty cool. So it's just printing out, here are the temperature readings. And if I hold my finger on the sensor, then you can actually see. So the temperature goes up as my finger kind of heats up the sensor. And then if I let go of it, you can see it'll start to fall down. And I like this sensor a lot because it's pretty fast to respond to changes in temperature. So that's kind of a nice thing. Now, the annoying thing is, because this is a while loop, and this program was really meant to be run at a terminal where you can press Control-C. If I press Control-C right here, it doesn't do anything. What you want to do is you want to go back to that kernel and run the interrupt command. And so that sends like a Control-C command basically to say, okay, stop running this while loop. And you could change this. Like I could maybe put a for loop in here. So like for I in range 10. If I just want to take like 10 readings. So if I run this, now it's just going to run 10 times and then stop. So that's probably how you want to think about your code here. Again, you're going to be kind of exploring and trying something, getting some results, and you're less likely to be like creating infinite loops, because when you've got an infinite loop, you're probably like making some kind of a program that you want to run forever. And IPython is not really the place that you want to put that kind of stuff. But as you're developing that program, it's a great place to like run some lines of code, see what happens, make sure you get the right code, and then put all that into like a main loop for your program. But okay, so you can see this just ran for 10 times. So this is pretty cool. Like we in just a few minutes here of running this, we were able to get a really nice interactive Python shell. And maybe if I wanted to be nice, I could say let's press A. We'll put a cell above here, and we'll put a markdown cell, and we'll say, let's give this a title. So we'll say this is like the MCP 9808 sensor test, and we'll say this example uses the MCP 9808 temp sensor to graph temperature readings. So again, I can put nice documentation inside of here that describes what's happening. Here's the example code for this. So okay, cool. So the last thing I wanted to show, I want to show real quick how to graph stuff. And there's a great little page, I'll put a link in the description below. It's from the IPython documentation. This plotting page kind of mentions a little bit, and they point to this plotting with Matplotlib notebook, which is right here, which I'll put a link in the description below too. You should definitely check this out. This just gives some basics of here's some code to use this Matplotlib library. And it's important to remember Matplotlib is separate from Jupyter. It is its own library. You don't have to use Matplotlib, but Jupyter is built to integrate very easily with Matplotlib. Matplotlib is kind of the default like Python graphing library, but there are a lot of other ones that are pretty nice and pretty fancy. Now, in order to use Matplotlib, you do have to run this matplotlib magic command, which is a little weird, but you just kind of have to roll with it. That's the convention they have. So I want to run this, and you just have to run this once, so I'll just throw it into a cell right here. And I think it's okay if it runs multiple times, so it's it's not the end of the world. And then to use it, you really just have to import matplotlib, like this line right here. They're also importing NumPy because they're using NumPy to generate some random data right here. Or not really random, but they're using it to generate some data. We're not going to do that, so I don't need NumPy, so I'm just going to import this top line right here, this pyplot part of the matplotlib module. So let's throw that into a cell right here, and we'll execute that. So okay, so now I've got this, and now it's actually the plot, the PLT command, well, PLT module that we imported. It has a plot command, and I can actually just give this two lists. I can give it a list for the x-axis and a list for the y-axis. So if I put like 1, 2, 3, 4 on the x-axis, and then how about like 10, 50, 100, 78 point, I don't know, 25, something like that for the y-axis. Now if I run this is pretty cool. So it just popped up a graph like in line inside of here. This blew my mind. I remember when I first started using these notebooks, because like I said, there's really not much like this kind of concept. There's certainly nothing like this in the physical world. A graphing calculator is kind of like this, but it doesn't give you this cool history, and it's not so much like a fixed history. Like I can go back and edit this stuff and rerun it and change it. I can evolve this, but really cool how it just dumps this graph in line. And so maybe I've got commands above that generated some data, and you can see how this graphed the data. So along the x-axis here, you can see 1, 2, 3, 4, 5, all those data points. And then on the y-axis here is the other set of data here. So that's really the basics of graphing. Now it goes a lot more advanced. I'm not even going to try to scratch the surface there. So definitely search around for Matplotlib and Jupyter, and you'll see all kinds of cool stuff. Most things distributed, because if you noticed, this documentation for how to plot with Matplotlib might look a little familiar, because this actually is an IPython notebook that they ran and turned into the documentation. So that's really cool when they're just using the tool to document itself. That's a very powerful thing, and speaks very highly of how well evolved the tool is that it can do stuff like this. But we're just going to do the basics here. So let's go back and let's just grab some of our temperature sensor readings, throw them into an array, and then plot them. So real simple stuff. So I'm just going to copy this code here, and maybe we'll put it into a new block that will start below here. And I'll just pull out some of the comments that I don't really need here. So we'll pull that out. And one annoying thing, for some reason, it seemed to pick up the tab characters, or it converted spaces into tabs, I believe, because I don't think this example uses tabs. But it got really confused, so I just deleted the tabs and then just pressed tab again, and it automatically inserted spaces. So I don't know, I think it's a weird quirk about how it imports some of the Python code. It could be a problem in my example, but I'm pretty sure I fixed all those spaces and tabs. Anyways though, okay, so I need an array, and like I said before, I just need to save this array of temperature data somewhere. So let's just call temps equals empty array. So I'll create an empty array inside of here. So every time this block is run, this cell, I'm going to switch this back to a while loop, an infinite loop. So we'll say while true. My assumption being that I'll run this for a little bit and then I'll interrupt that kernel to stop it. Maybe not the best way to do it, but it works. And then I'll keep the code where it prints out the temperature reading, but let's just append to our temperature. So we'll say temps.append, and let's just add the current temperature in Celsius to that. And so every second it'll take a new reading and put it in this temps list right here. So we'll hit enter, and you can see it's running, and then I'll hold my finger on here, and the temperature goes up a little bit, and then maybe I pull my finger off, and the temperature falls back down. And then to stop this, remember I just want to go up and do the interrupt command. So okay, so that stopped. Now if I go into a cell below this, remember all of the state still exists. So this temps variable, it's a global variable, it still is there. So if I just type temps and hit enter, it's showing me here are all of your temperature values that we recorded. So that's pretty cool. Now if I want to plot these, it's pretty easy. I just do plot.plot, and I don't even have to give it the x-axis. It will just generate like 1, 2, 3, 4. So I'm just going to throw that temps array directly into it. And hey, look at that. So it figured out that like this is data that's increasing over, maybe it's time. It doesn't really know what this x-axis is. It's just throwing some increasing values there. But here's, where I touched the sensor and it went up to like 25 degrees Celsius, 26 degrees almost, and then kind of fell back down after that. So really cool how, again, like I mentioned, if you're just exploring something or learning about something, especially if you're learning Python and learning programming, this is a perfect environment to have, you've got your guide open maybe on one tab, and then you've got your notebook open and you're going through this and you're saying, okay, I need to run this command. So I'm going to copy it out and put it into this, or I'm trying to run this example. So I'm going to copy out, this bit of code right here, and maybe throw this into a new block right here and start running it. So really cool, and it's neat in that you get this history of the results that are saved inside of here. You can document it. If I'm really nice, I'll put a cell above here, and I'll convert this to markdown, and I'll say like, here is where I run the example from the guide, something like that. And so when you come back later to this, you're like, okay, what was I doing in this block of code? Oh yeah, I was smart and I told myself what I was doing inside of here. Because you could put comments in here. So this is Python code. I could say, example from the guide. But it's really nice how you've got this flexibility. If I wanted to format this, Markdown is a lot more a richer kind of language. And in fact, like our guide system, it's not completely based on Markdown, but it's pretty similar. So, you could almost like create a guide inside of an IPython notebook. And if I remember, Lady Ada was saying that IPython was kind of an inspiration for the learning system, because if you look at our learning system, like we've got description and code all interleaved inside of it. And so that's a powerful thing. So this is starting to run a little bit long. I think I'm going to wrap it up, keep this pretty kind of short and easily digestible. But this is a quick look at IPython or Jupyter, Jupyter, the Jupyter project, which gives you a notebook to use code and documentation and really explore a subject, whether that subject is data analysis of, like web traffic across millions of servers, or maybe that, area is embedded hardware on a Raspberry Pi that you're trying to read sensor readings from or something like that. It's all Python code, and it's stuff that can go into a notebook and you can really use as a platform for learning and exploring. And I think, especially for like teachers and classrooms, this is something that is well worth checking out, because it gives you a very nice, more friendly environment, versus if I wasn't using IPython right here, I'd have to be like creating scripts on the Raspberry Pi, using maybe a text console editor that's not very friendly, or maybe a slow GUI editor running on the Pi that's not going to be as usable as something faster, or maybe I'd have to be writing the code on my computer and copying it over to the Raspberry Pi, which is problematic and annoying to do. So this is great. Like, you've got a web interface, because hey, it's 2016. The web is taking over everything. So this feels like a more natural way to use programming and explore something. So that's Jupyter, and I just want to do this little quick look to kind of mention what it is, give you some pointers to it. Again, look at the links in the description below. I'll point you towards some of the documentation so you can check it out and see what makes it interesting. So if folks have questions, throw them in the chat, and I'll see if I can get to them real quick. And we'll jump back to the main view. And hopefully this main view is working. I noticed in the last few videos, it gets really stuttery right now, which is completely bizarre, because it's telling me that I'm only at like 70% CPU usage. Usually when your video gets stuttery, you've got like something using your CPU. I think it's a bug in Wirecast. I don't know. There's a new version of Wirecast out though, so maybe it fixes it. So apologies if my face is all like acting like Max Headroom or something like that. It kind of looked like that. The audio at least is good. So, and it's only in this main shot. And when I go back to the desktop shot, which has this as a smaller window, it's fine. There's never stuttering. So I don't know what it is. Blame Telestream, the Wirecast creators, for that. Anyways, though, oh yeah, someone's mentioning that Jupyter looks like the source for the Swift Playgrounds idea. Yeah, exactly. So there are a lot of projects that I think have been inspired by Jupyter. So Swift Playground is a tool from Apple, I believe, that helps you learn the Swift programming language using that same concept of like, here's the code, here's the explanation, all interleaved together. You know, very powerful thing. Like I was mentioning, it goes back to that literate programming concept that I think Donald Knuth actually was a big proponent of. So it's, you know, it's not a new concept, but Jupyter has definitely done it very well, and everyone else is kind of following it. So okay, so I think that's it. No more questions. So I'll wrap this up. So this is Tony from Adafruit. Check out youtube.com/Adafruit. You can watch this video and all kinds of other fun project videos there. Check out twitch.tv/Adafruit. That's where I like to stream live too. So if you want to see this live, you can check that out. We do all kinds of live streams during the week. So there's like Desk of Lady Ada, Noah and Pedro have 3D Hangouts layer by layer. So tune in, check that out. I like to stream on Mondays. I'll do a quick look like this. And then on Fridays, I do a more in-depth stream. So this Friday, I'll do part 3 on the Raspberry Pi cat laser project. So if you like cats and you like Raspberry Pi projects, check out YouTube. You can see the previous 2 videos. And then this Friday, I'll stream a new one. And then next week, I won't actually have any of my regular streams because I'll actually be out in New York. So I'll be at the mothership or the home base. So I'm sure there could be some streaming and stuff going on from there. So keep your eyes peeled. And then end of next week, there's the HOPE conference, the Hackers on Planet Earth. So I'll be out at that one too, and checking out, you know, what's going on there. So anyways, though, I'll wrap it up. So thanks a lot for watching. You know, like, comment, subscribe. If you find this information useful, then, you know, let us know. This kind of keeps us going and lets us know that people like this stuff, and we'll keep creating this kind of content. So thanks a lot. This is Tony from Adafruit. I'll see you guys later.